a list of numbers might keep getting bigger and bigger. I want to precisely define increasing for sequences. A sequence, a sub n, is increasing if whenever m is bigger than n, then the mth term is bigger than the nth term. This is capturing the idea that the terms are getting bigger as I go further out in the sequence. Let's take a look at an example of an increasing sequence. For example, the sequence a sub n equals n squared is an increasing sequence. I can write out the first few terms. The a sub 1 term is 1, that's 4, 9, 16, right? These are just the perfect squares. And the claim is that this is an increasing sequence, that as I go farther out in this sequence, the terms get bigger. And to really convince you of that formally, what I need to show is that whenever m is bigger than n, then a sub m is bigger than a sub n. And indeed, that's true, because a sub m is m squared and a sub n is n squared. And as long as these m and n are positive, this is true whenever this is true. We can also consider a sequence which is decreasing. A sequence, a sub n, is decreasing if whenever m is bigger than n, then a sub m is less than a sub n. This is capturing the idea that the terms are getting smaller. It's telling me that larger indices correspond to smaller terms. So as I go further out in the sequence, the terms are getting smaller. It's easy to build examples of decreasing sequences. Well, if a sub n is an increasing sequence, so an example of this would be the example we just saw. An example would be a sub n equals n squared. Well, if I've got an increasing sequence, then the sequence b sub n, defined by just negating the terms of a sub n, is a decreasing sequence. Right? If the terms of a sub n are getting larger, the terms of b sub n are getting more negative, they're getting smaller. Why even bother with all of this? Well, basically, I just want to give definitions for the kinds of qualitative features that we might be interested in. We might be interested in a sequence that's increasing or a sequence that's decreasing. We might also be interested in a sequence which maybe isn't necessarily getting bigger, but at least it isn't getting any smaller. Is non-decreasing if whenever m is bigger than n, then this isn't the case. And to say that isn't the case means instead of less than, it's greater than or equal to. So a non-decreasing sequence is not getting any smaller in the sense that future terms are at least as large as previous terms. Here's an example of a non-decreasing sequence. The sequence might start 1, 1, 2, 2, 3, 3, 4, 4, and so on, where it sort of repeats itself. This sequence isn't increasing because later terms are not larger than earlier terms. 2 is not greater than 2. But the sequence is non-decreasing, right? At least the terms aren't getting any smaller. Not very surprisingly, we can also define non-increasing. A sequence is non-increasing if whenever m is bigger than n, then a sub m isn't bigger than a sub n. And isn't bigger means less than or equal to. So a non-increasing sequence is, well, not necessarily decreasing, but at least it's not getting any larger. So thus far, we've talked about increasing and decreasing, non-increasing and non-decreasing. Generally, it's just interesting if a sequence is heading in the same direction, if it's any of those things. A sequence a sub n is monotone if that sequence is increasing or non-increasing or decreasing or non-decreasing. So monotone amounts to just a fancy way of saying heading in the same direction.